Welcome to Electronics Made Simple by Wadekar Madam's channel and all the best student for your 12th practical exam. Today we'll perform op-amp as adder. To perform this practical, in question A you have to draw this circuit diagram and then you have to write specification of an op-amp. You see that as per this IC and all this theoretical part you have to write specification of op-amp. To perform this practical, first we'll connect digital multimeter and we'll check dual power supply. See, in this digital multimeter, this is dual power supply up to 9 volt, right? You can see the front panel control of this digital multimeter. Now we'll connect this battery voltage. Now in this kit, this is already connected here IC741 with this different connection V1, V2, V3. These are the three input given to the inverting terminal of an op-amp, and non-inverting terminal we have to ground here. You can see in this diagram here V1, V2, V3 togetherly connected to the pin number 2 and pin number 3 is grounded. Now see here, I will connect this V1 to this first potentiometer, V2 to this second potentiometer. Now I have to give negative supply to V3, so that I will connect this V3 terminal to here negative terminal of this power supply and this positive to the ground. Pin number 3 should be connected to the ground. Now we have finished the connection to perform this op-amp as adder. Now we can vary the voltage across V1 and V2 with the help of this potentiometer 1 and 2 respectively, and we can vary voltage across V2, here this V2, as per our requirement with the help of this DC supply. But this is variable DC supply. Now we'll check first V1. Suppose V1 is 0.5. V1 is 0.5. Right? See in this digital multimeter. Now V2 is -1. I'll take V2 here from this supply V2. Let us check V2. -1 I have to adjust. I can adjust with the help of this regulated DC supply. It should be -1. See here, this is -1. Okay. Now V3 is 1.5. Students, I have made some changes here. Instead of V3, V1 is negative here, and now I have connected V3 here. So V3 I will vary here, and you can check here we have to adjust V3 1.5. Okay, now this is 1.5. Now we have to check output. As in this truth table it is given that V1 0.5, V2 -1, V3 1.5. Calculated output should be 1 volt. See here output, this is nearly equal to 1 volt. Calculated is 1 volt -1 volt. It should be negative because we have connected all the input to inverting terminal of an op-amp. And what about this observed output? This is -0.97. Students, in this way you can check for other connection by giving this different combination, including one negative voltage for each combination of all these three. Okay. Now in second question we have already performed offset nulling. This is C question. We have completed all this part, and in D question you have to write expected, that is calculated value, and observed value. So you can repeat this table in part D. Now in part E, you have to adjust output of this adder circuit without giving input 0. So we have to adjust output 0. Now see how can we adjust in part E. For example, first we have to adjust this input voltage is about 1. So I will vary this potentiometer. See, this is here 1, right? Okay, 1. Then we have to adjust this V2 minus 1.5. So with the help of this separate supply, I can adjust. See. Okay, this is minus 1.5. Minus 1.5, and at last V3 should be 0.5. Then and then only we can adjust output 0 without giving 0 value or with non-zero input. See, now this is 0.5. Okay, so finally output should be 0. Okay, right? So here this multimeter shows us ideal value, that is 0. Means as per this truth table we have already adjusted this value V1 1, V2 minus 1.5, V3 0.5, and definitely will get output 0. And at last you have to give orals. Okay, thank you.